Question number 46. So we have been given a reaction sequence which is leading to the formation of the product B, and the examiner seems to be interested in some reactions of the product B. So if we try and figure out the reaction sequence, so we have this structure undergoing hydroboration oxidation. So we can call it HBO DBO for hydroboration deboration. So it is going to lead to the anti-Markovnikov addition of H and OH without the rearrangement of carbocation. So we are going to have an OH added at the cyclic carbon of the double bond. So this is our product A. Now this product A is subjected to oxidation using PCC. So the PCC will convert this alcohol into a ketone. So this is our product B. And the product B will not give tolerance test. The product B will lead to the formation of a cyanohydrin on addition of HCN. This is correct. This compound B will also not give Felling's test, as it is a test for aldehyde. And the structure B will lead to a positive 2,4-DNP test. So the examiner seems to be interested in the reactions which is given by the product B. So we have to select option 4 as the correct answer to our question. Let us look at the next question. Question number 47. So we have been given a compound P which is first allowed to react with HCN. So students, the HCN will add to this carbon double bond oxygen and lead to the formation of cyanohydrin. So this is next subjected to reduction using H2PT. So the H2PT will convert this cyanide group into CH2NH2. Next, this compound is allowed to undergo reaction with nitrous acid, HNO2 at 0 degree C. So this HNO2 will convert this NH2 into diazonium cation, and this diazonium group will leave, leading to the formation of a carbocation at this carbon. We are drawing the intermediate. And now in order to stabilize the carbocation, this group will migrate, leading to the formation of a 6-membered ring. Now students, the lone pair over oxygen will stabilize this carbocation and it will itself lose a proton, which will lead to the formation of 3-methyl cyclohexanone as the end product P. So students, we have to select option 3 as the correct answer to our question. Let us look at the next question now. Question number 48. In the given reaction, so we have a cyclic ether which is allowed to react with HI. So in the first step, the H plus will protonate the lone pairs over oxygen. Now in this structure, students, we have the possibility of formation of a tertiary carbocation, and we know that the tertiary carbocation is formed. So the reaction will proceed via SN1. As the tertiary carbocation is very stable. And in the second step, the iodide ions will attack this carbocation, leading to the formation of a tertiary iodide. So this is the major product P obtained in the reaction. Students, the major product P is correctly represented in the first option. So we have to mark option 1 as the correct answer to question number 48. Let us look at the next question. Question number 49. So we have butenes. So in reaction 1, the cis form of the butene is allowed to react. In the second reaction, the trans form of butene is allowed to react. So the reagent is the same in both cases. It is peroxyacetic acid in both the cases. So students, we know that the peroxy acids on reaction with alkenes, they lead to formation of epoxides or oxyranes. Now students, if we talk about this reaction is a stereospecific reaction, which means that only one single stereoisomer is specifically formed in the reaction. So if we have a cis alkene, the cis alkene will give us a cis structure and the trans alkene will give us a trans structure. Okay. So if we talk about the structures A and structures B, so structure A is going to be a cis epoxide. In which both the methyl groups are cis to each other. So this is our product A. And if you look at the product B, the product B was originally a trans molecule, and it is also going to lead to the formation of a trans oxyrene, in which the methyl groups are anti to each other or trans to each other. So students, if we look at the optical activity of A and B, as the examiner is interested in that, so we can clearly see that the structure given in A has a plane of symmetry, whereas the structure given in 2 does not have a plane of symmetry. So this is optically active. And students, we know that optically active structures are generally formed in racemic mixtures. So the compound B will be racemized, whereas the compound A will be a mesoform. So if you look at the options, we can see that the correct option is given in statement 4, where it says that A is optically inactive, as A is the mesoform, and B is enantiomeric pair, as it consists of a racemic mixture of both the enantiomers. So we have to mark option 4 as the correct answer to question number 49. Let us look at the next question, question number 50. So we have been given a cyclic ether, which is allowed to react with 2 different reagents. In the first reaction, we have methoxide ion attacking. In the second reaction, we have methanol, which is attacking. So if we talk about the reaction leading to the formation of product A, in which methoxide ion is attacking, so this is a good nucleophile and it likes to make an SN2 attack. So the SN2 attack is going to happen at the least hindered carbon. So the least hindered carbon in this case is the carbon at the right. So the MeO minus will attack at this carbon and make this bond leave. So we are going to have the formation of C2H5, CHOH, and CH2OMe. So this is the product A. And if we look at the reagent leading to the formation of product B, we have the case of solvolysis in this case. So what is going to happen is the epoxide will first get protonated by the H+, which is coming from H2SO4, and as the methanol is a weak nucleophile, so it will undergo solvolysis, and the solvolysis of oxyrenes happen via SN1 type, which involves a cationic transition state. So this methanol molecule will attack that carbon at which the feeling of formation of carbocation is greater. So if we look at these 2 carbon atoms, the carbocation formation feeling will be greater at this carbon as it is stabilized by the R group which is attached to it. So this methanol will attack at this carbon and making this bond leave. So we are going to have the formation of C2H5 plus the ether will be formed at the branch carbon and the alcohol will be at the terminal position. So this is our product B. So if we look at the options mentioned to us in the question, we can see that the correct answer is in option 1. So we have to mark option 1 as the correct answer to our question.